This exam question tests your understanding of circular motion. Let's get started. A student determines that the time taken for 10 revolutions of a mass being whirled horizontally on the end of a string, which is 0.5 meters in length, is 8 seconds. Calculate the centripetal acceleration of that mass. Pause the video here if you'd like to attempt this question before we cover the solution. Okay, as always, we should start by drawing a diagram of our situation. In this case, it's very simple, but it's a good habit to get into. So we have our circular path in a dashed line, we have our center point in the middle, and our radius of 0.5 meters, which is the length of our string. And then we have our mass at the very end of that string. To start, we know that the time taken for 10 revolutions is equal to 8 seconds. And we need to convert this to time taken for 1 revolution so that we can determine velocity in the future. So time is equal to 8 seconds divided by 10 revolutions, which gives us 0.8 seconds per revolution. Next, we assume that the velocity of the mass remains constant throughout the entire circular motion. Therefore, we can use velocity equals displacement on time, which is on our formula sheet. We know that time is equal to 0.8 seconds, but the trick here is to remember that displacement is equal to the circumference of that circular path. So S is equal to 2 pi r. From this, we have V equals 2 pi r divided by time, or V equals 2 times pi times 0.5, all divided by 0.8. From this, we can find that our velocity is equal to 3.93 meters per second at a tangent to the circular motion of the mass. We can now go back to our formula sheet and find the equation for centripetal acceleration, which is AC equals v squared divided by r. Subbing in our newly calculated velocity as 3.93 and our radius as 0.5, we can find the centripetal acceleration is equal to 30.9 meters per second squared towards the center of the circle. Don't forget that we must add in a direction in which our acceleration acts or we will lose marks. Same goes for our 3 significant figure form for our final answer. Thanks for watching. Check out our playlist on circular motion exam questions for more work solutions on this topic. See you next time.